Okay, sweet. Didn't forget to record this time, so. See, do I? Hello, 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 hello. Hello, 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 hello. Nice. Okay, one more minute. I'll just. Okay. We're gonna go ahead and get started, and then people who weren't able to make it today, they can just watch it through the recording. But yes, welcome everybody. Welcome to lecture 10/11. Sorry, I wasn't able to come in and do lecture last week. I was feeling a little sick. So this is just a combination of last week and in this week's topic. And then in 2 more weeks after Thanksgiving break, we have our final lecture, and then we're all good. And then we have like the final project we're releasing soon. So more info on that. But thank you all for coming. Some quick announcements. So a lot of people have been having trouble finishing up lab because of other classes. The strike's going on, right? So a lot of resources like office hours haven't been available for a lot of students. So we're extending that to Monday, which is November 21st. And then if you need any help, I saw some people on Ed had some questions or had some bugs that they were facing. If you guys need any help, shoot me an email and I can send a Zoom link and accommodate to your schedule and figure things out and help you debug. So that will be an option. Quiz number 10/11. This is one quiz, by the way, not 10 and 11. Quiz 10/11 is released tonight. It'll be due next Thursday, or actually the Thursday after Thanksgiving. And then the final project will be released Monday. I'm gonna figure out all the specs for it, but basically we're gonna pick from like a list of AWS like approved projects that you can kind of do on your own, and then like put out 3, and then you can choose, follow the directions, send a screenshot of completion, and then you'll receive credit. So it's not too bad, not too hard, should not take more than a couple hours or even less. So the goal is to make sure that it is very suitable and doable before finals week. And then 2 more topics we're going to be talking about today: infrastructure, which was last week's topic, and networking, which is this week's topic. So we'll go ahead and get into it. I forgot, I think there was one more thing I forgot to mention. Yeah. Oh, also, we're starting to grade a lot of the assignments. So apologies for not knowing your like full quiz or lab grades. We're finally figuring out an organization to actually grade those. So you should be seeing grades throughout the week, this weekend and throughout next weekend. And this includes your attendance, so you can kind of see which ones you need to go back and rewatch to put in the attendance codes. But remember, this is a PNP class. So as long as you're doing above 70%, no, correct me if I'm wrong. I think it's lower, it's a lower threshold, I forgot. But as long as you're doing fairly average, you'll be able to pass. So no stress. It should not be a surprise if everybody in this class passes. But yeah, other than that, let's get started. So first topic is infrastructure. This is kind of going a little bit back to our first lecture where we were kind of introducing the topic of cloud as a whole, but this will kind of revisit that and explain a little bit more on the entirety of the AWS cloud infrastructure. So the AWS cloud infrastructure, as you remember from our first lecture, there's things that are called AWS regions and availability zones. So the entire cloud infrastructure, or like the system of the cloud in AWS, is built in these areas. So in AWS regions and availability zones, that's where all of your cloud technology is actually hosted. But you as the customer or user, you don't necessarily have to care about that. That's all on AWS's end to get set up and to offer you as a service. So yeah, AWS regions are located all across the world, and availability zones are subsets of AWS regions. So one AWS region can have multiple availability zones. And in each of these availability zones, they have their own data centers, their own facilities. So all the AWS services you use come from these data centers and facilities. So we can go ahead and click this link to kind of show you how vast AWS is and how many regions there actually are. So if you look over here, we have, this is Northern California's region. This is the one we're using whenever we launch AWS and, you know, create our own instances of services. So this one is in Northern California. It was launched in 2009, and individually there's 3 availability zones within that. We also have US West, which is like a more broad availability zone or slash region. And then we have, or it looks like it's coming soon, but there's going to be a Canada AWS region. So that's cool. People from Canada and Alaska can connect to this one when they're using services. And you can see here it's spread all across the globe in every continent. And it's only up from here. So AWS is going to keep expanding their resources to do so. And it's pretty cool. We have one even in Africa, near South Africa, and then a lot in Europe. So this is interesting as well. And then not so much in Russia, but a lot of areas in China, Australia, India, etc. So you can see there's just quite a bit of regions. So you know that you can kind of see like the subsets of edge locations. We'll talk about that later, but each region has their own availability zones in certain cities. Knowing this, that means that you'll never have to worry about whether or not there's AWS availability in the world. So it's very convenient. You as a user don't have to worry about that. That's growth on AWS's end. So yeah, that's the global infrastructure. It's just basically the system that is spread out across the world for us as customers to use their services. So why do we talk about the infrastructure of AWS and why is it important? This is kind of going back to cloud computing as a whole, but more specifically tailored to AWS. There's 6 main benefits to the actual infrastructure that allows it to be such a nice company and such a nice service to use. We have a really high quality security in all of AWS's infrastructure. We have high availability, high performance, very, very scalable systems and very scalable technology. We have a lot of flexibility. So you as a user have a lot of choice and a lot of adaptability on your end. And then there's a huge global footprint that AWS has, which means like there's a lot of influence that AWS can have in the global scale. So these are like the 6 biggest reasons for why we talk about the global infrastructure of AWS. And you can kind of see they have their own respective logos that are kind of cool. But to talk about the first one, little throwback to the first lecture, right? We talked about security, flexibility, adaptability. We're going to be more specific in AWS. We're going to talk about security. So basically, the reason why AWS is so secure is because data that flows through the entire infrastructure is always encrypted, and you're knowing that all your data centers and your server centers, they're all protected 24/7, have high security gates. There's recovery systems that allow certain servers to reboot in a different area if one goes down. These are all measures that have been ensured by Amazon to make sure that your services are there for you. So if you look at the pictures here, you have these massive racks, right, full of different servers. These are all highly protected. There's probably guards at the front of this building, much like the Ant-Man movie. Remember when Ant-Man was trying to sneak into like that one facility or whatever? You can kind of see like there's security guards. It has like the same vibe. It's very highly protected. And I'm sure the security guards get paid a lot too for guarding such high quality information. But that's that. And then, yeah, you can see these cables of like, I don't know how many inches width and radius. They extend through the floor, all of the data that's sent through, and packets is all encrypted. So your information is secure. You will never really have to worry about data leaks or anything like that. So yeah, security in AWS, top notch. Next is availability. So availability is kind of like the idea to be able to access your applications from a multitude of different areas. So when you're building your AWS application and you want your users from across the world to access it, they can do so by you spreading up your application across multiple availability zones. So things like your EC2 instances, you can have different instances in different areas, for one in Europe, one in South America, target users all across the world. And you don't have to worry about whether or not one group is being left out or discriminated in location. And then your AWS Management Console and the control planes that handle all of the instances that you create, this can be accessed across all regions. So you're sure that whenever you need to access your AWS systems and services, you don't have to worry about like where you have to be or whether or not like you're in the right location to access them. You can basically access your AWS services at any area in the world. And then to kind of quantify how available AWS is, we have 29 regions and coming, and then 93 availability zones. So that's only growing from here on out. As soon as they start investing their profits back into the company and building infrastructure, that's kind of the idea. So like, for example, this is the AWS Management Console. You can access this console anywhere across the world. You can access the one you see in North America or North California would be the same one you see in China, for example. And you can kind of see in every region, we have individual availability zones. So for example, in North America or North California, you have US West 1, North California, US West 1A, 1B, 1C. So those are like individual availability zones with their own data centers. And you can make sure that your applications spread across different ones at different times. So yeah, availability, very high volume of users can access your application anywhere across the world. Next is performance. So performance is very high in AWS. That's one of the key defining characteristics. You can ensure that your applications will always have low latency and low packet loss when in junction with the customer's end. Your AWS services and infrastructure from end users and 5G devices can be to the millisecond in latencies through some other services, but you can ensure latency and connection to these services is never an issue. So you would never, as a customer, have to deal with the frustration of low response times, or as a customer's customer, like a developer's customer, when you're using someone else's application, you will never have to worry about connection speeds either. So to give a brief background about latency, because it's not like talked about too much in CS classes, unless you're taking like networking and some other ones, but basically latency is just the response time. It's the response time, which is like the sum of the time it takes for you to send a request and receive the response back for that request. So if you look at this diagram, a user sends a request to a server, takes 250 milliseconds, and it gets a response in 300 milliseconds. In total, the latency would be 550 milliseconds. But that's crazy because we're going to click on this AWS latency test. Let's connect to, okay, we're going to connect to our closest available or AWS region, the US West and Northern California. Let's look at the latency of connecting to that. So now in traditional software development and in networking, any kind of latency below 100 is considered good, and any latency below 50 is insanely good, like very good. And look at this, we're in less than 50, sub 50 latencies, and even less. depending on certain times. But yeah, that's really high quality response times. You're knowing that all the services you're interacting with are going to have instant response times to us as users. And then let's try to connect to Seoul or Seoul in Korea. Korea is like halfway across the world, right? And we're still getting latency of less than 1 second. So that's pretty darn good. Let's try one more. Let's try, where's the one in Africa? Cape Town. Let's see here. So connecting to Africa's region and availability zones there, we're still getting latencies above or below 1 second. So, you know, for example, you send an HTTPS request as a customer to like an application that is hosted in Cape Town, you know that your response time is going to be less than 1 second, which is very good. And it's a really nice guarantee. Like your customers are going to be very satisfied with being able to see whatever they want to see as part of the request. So yeah, very high performance. So that's reason number 3. Number 4, it's very scalable. You know, when we spin up EC2 instances, for example, or we have different S3 buckets and we want to expand our volume of S3 buckets, you can do that. And AWS is perfect and allows you to optimize those efforts. So you can ensure that the cloud has enough resources for whatever business needs you have. We know that in AWS, the scaling is blind. So that means you can vertically scale or you can horizontally scale. And I can explain that in a second. Basically, when you want to vertically scale, that means you want to increase something about an individual or a group of servers. So for example, if I want more computational power for my EC2 instances, or I need more capacity for those EC2 instances, vertical scaling allows you to do that. You can buy better hardware or better EC2 instances with clouds or AWS's cloud tech. And horizontal scaling is like the other way. So rather than building something up and increasing computation and capacity, we're horizontally scaling. That means we're getting more quantity. So rather than having one EC2 instance that you have really high computational power, you can have multiple EC2 instances that might have the same power, but achieve something that you might not have achieved with vertical scaling. So for example, you could split your application across multiple EC2 instances instead of having one that is dependent on one EC2 instance, because if one goes down, you're in trouble. But when you have 3 going on, one of them can take the load off the other when this one comes down. So yeah, that's horizontal and vertical scaling. You have that option in AWS. And you can deploy thousands of servers within minutes. You don't need approval for any of those things. And it happens very quickly. So whatever your use case might be, you can do so. So very scalable, very quick, and vertical and horizontal included. The fourth, or this is the fourth, I believe. Yeah, no, fifth. The fifth reason is flexibility. So flexibility is more on the user side, so the customer side of AWS. When you're a customer, right, you want to have the opportunity to choose, have options. You want to be given the burden of choice, because this allows you to develop complex solutions for your business model or, you know, your personal project. Those are nice troubles to have. Rather than like be presented something on a plate, you have the opportunity to cook something up. So that is flexibility in AWS. For example, you know, when you're having your business or project run on infrastructure, you could have it be on premises or in the cloud or even both. So you have like the opportunity to have your services be just where you live or like where your work is, or you can have it be in the cloud. Those are options you might have and you can choose. That's good because, you know, in certain scenarios where you want to maintain your own data centers or your own servers, you can integrate other AWS servers to kind of offload some other things to the cloud. So that's a nice option to have. And then you can choose where, when, and how your workloads are ran across the availability zones. So you're not blind to location. You can have your services run worldwide. And then last but not least, the biggest reason is cost, right? When your cost is low, you're very happy. So costs are always optimized for your needs. You have a lot of flexibility in choosing different payment plans, and different services have different types of billing. So you know that you can always try to find the best service with multiple options of payment. And there's trade-offs, and that's up to you as a consumer to decide. And you can see in these diagrams, there's just so many AWS services that are top-notch and are quite frequently used. So this is a nice diagram, but this is just a subset. There's even more miscellaneous ones, but like these are kind of like the bigger ones. There's so many different tools for analytics, for databases, for computing, storage. There's so much. So you have the flexibility as a user to be given so many of these ingredients to make a nice dish. And then last but not least, global footprint. You have the opportunity to access AWS's infrastructure that has global influence, right? Because AWS is a leading standard, your applications are kind of globally inclusive. Anywhere across the world, that AWS is able to be accessed. So any service will thrive in all regions and availability zones. And when I first read this reason, I thought global footprint meant like, oh, AWS is like climate friendly, like they have a lot of climate practices. That's actually sadly not the case, because they're running millions of different servers. So their carbon footprint is very high, but their global footprint is even higher. So yeah, AWS, they do have some movements to try to create sustainable data centers, but in terms of footprint, global footprint, it means their influence, not their climate dedication. So yeah, that's something I just wanted to point out because it was funny. But yeah, those are the 6 big reasons for why the infrastructure is so important in the global scale. Does anybody have any quick questions about any of those reasons, or any more broad questions about AWS as a whole before we move on to a little bit more of like a fun topic? Okay, sounds good. So like throughout the semester, right, initially we were talking, many people asked, like, are we only going to be focusing on AWS? What about Azure? What about Google Cloud? Like, are we only going to be talking about AWS? Initially, right, we were like, yes, our main focus is on AWS. The reason why do we talk about AWS so much is because AWS is just so versatile in the technology you learn. And when you learn about Amazon Web Services, you can practically translate a lot of that skill to other cloud platforms. And it just so happens to be convenient that AWS is the leading industry standard. You can have a lot of options here. You can see there's different smaller, but still very effective cloud platforms like IBM Cloud, VMware, DigitalOcean, and then Azure, which is a close runner-up, Google Cloud Platform, which is like a third place kind of cloud platform. But yeah, AWS has always been the industry standard, and that by being involved in AWS, you're learning skills that you can very easily translate to different platforms. And yeah, there's so many different reasons for why AWS specifically. So let's get into those. So some quick main reasons. Number one, it's the fastest growing public cloud in the world. I don't want to come off as an AWS like fanboy or anything, or like, trying to promote AWS. We're not sponsored or anything, but these are just some very helpful things to keep in mind when you're trying to learn about cloud computing, because it just so happens to be the most resourceful service. But yeah, it's the fastest growing public cloud in the world. High revenue, which you'll see soon. Number two, AWS skills are really high in demand. So there's always going to be individuals in companies, enterprise scale or locally scaled, that are looking for people who know AWS and know how to work AWS technologies. Because you as a student, right, when you first learn about these technologies, it's very intimidating and very hard, and it takes time. A lot of companies, when they're trying to get their products running up and spinning up quickly, or their infrastructure, they don't have necessarily the resources to learn all of that in such a short amount of time. That's why they hire so many people. So yeah, AWS skills are high in demand. There's increased enterprise migration to the cloud. So more traditional business models are moving to like a more hybrid or even a solely cloud-based infrastructure, just because of cost benefits and other accessibility reasons. And then AWS roles pay a lot of money, which you'll see soon. And AWS is affordable and easy to learn if you know how to play your cards right. So to kind of dive into each reason a little bit more in depth, for example, this is a statistic. AWS was launched in 2006, and there was around 180,000 developers or like consumers on the platform. Now it's probably 4 times as much, 4 to 5 times as much. There's more than 1 million different developers with different use cases and different companies with different skills. So you can see in a matter of 16 years, right, we're almost this is like an exponential kind of thing. And then in terms of revenue, in 2015, like the revenue was 6 billion, which in itself is a really big number compared to Amazon as a whole. And now it's 20 plus billion in 2022. So look at this chart right here. You can kind of see this is a nice little growth. This is what you want to see in a company. And fun fact, a majority of Amazon's profits actually come from AWS, not Amazon.com, which is surprising because Amazon.com was like, their biggest pulling factor, right? But they've done some cool and I would say smart on their end tactics to try to find other revenue avenues for revenue. So yeah, very high demand, very high growth. It's not leaving anytime soon. And too many companies rely on AWS for it to just collapse. So that is another important thing to keep in mind. So to kind of show you the demographics of how fast it's growing, this is just a recent Q2 2022 diagram. You can see how dominating AWS is in the market. Azure is at 21%, 1/4, but AWS is 1/3. And compared to all the other cloud services, they're still trying to catch up in terms of revenue growth and infrastructure. So yeah, reason number two, high demand of AWS skills. This is just a fun fact. So on Indeed, there's a statistic that showed that 70,000 plus cloud job postings existed, and a majority of them were AWS related. So they were looking for AWS related skills in infrastructure, skills in developing in general, and skills in security. So there's high demand, and there's not enough people to meet that demand currently. So it's nice to be able to be involved in these kinds of technologies early on, because they're always supplemental in the industry. Whether or not you want to go into cloud, it's just always nice to have this kind of jack of all trades trait to your candidate profile. And there's probably even more outside of Indeed. Third reason, enterprise migration. So back in I forgot to add, I think it was 2015, around 77% of companies were like relying on traditional ITs. So that means like managing their own data centers, their own databases, keeping track of all of their networking, things like that. That number has dropped a little bit to 43%. In terms of like how big that is, it's pretty big when it's relative to like the amount of companies at the enterprise scale. So a big drop to 43% in 2018, that number is pretty surprising, right? And you see that a lot of enterprise migration to AWS, that means more revenue, more job opportunities, and also more potential for growth. And cloud services, this is another reason why AWS jobs are so high in demand. Part of the migration to the cloud is there's actually not that many people that know how to actually do that. So there's another byproduct of this migration. People in companies are looking for professionals who are able to help them migrate to the cloud. So there's even jobs in that. So a lot of cloud services, they're automated, right? But the actual migration of an on-premises enterprise to the cloud is not. People actually need to be on site to manage that and to go through that and to figure out solutions for that. So yeah, more opportunities there when enterprise migration is high. And I'm sure this number is going to drop even more just because of how cheap it is and cost efficient it is to run stuff in the cloud. And then that's the fifth reason is high paying roles. This is some fun statistics. I need to put the sources down, but for example, an AWS certified solutions architect, those are just individuals who know everything about every AWS service, how to integrate them, where to do what, those kinds of things. They make plus six figures plus on average. And this is even more than the top 15 IT certified professionals. So you can kind of see like this new generation of IT/architecture coming and arising. AWS Enterprise Cloud Architect, these are big company professionals that are aware of how to manage big workloads and big infrastructure and architecture. Those make even more, those roles. And then Senior Cloud Solutions Architect, those are individuals who are like suitable for like any type of cloud role, but they're very experienced in them, have developed in the past. They make a nice 132,000. So yeah, you can see there's job opportunities here as well. So, you know, if you don't have the correct skills to do well in like SWE or like, you know, data science, things like that, you can learn AWS skills by playing around with AWS.com, and you can find yourself a nice job just because it's so hard to learn because you need the time to do so. So yeah, this is a nice backup plan. If things don't work out and you don't like to code, you can be a professional in AWS. And it's kind of funny because, you know, this is like very company dependent. So your skills are reliant on AWS. But if it pays, it pays. So it's something to think about and always good skills to have. And then there's some more statistics according to Indeed.com. I believe this was in 2010 or 2015. No, it might have been a little bit later, but for certain skills associated in the job title, they had very high paying salaries. So especially DynamoDB, it's such an industry leading standard for databases. They pay very high, and all the other services down here, the most frequently used ones, they need people to manage those in integrations. So that number is also high. So yeah, very much good market to go into. And then last but not least, affordability within AWS. You can kind of experiment in the cloud free of charge because there's the AWS free tier. So when you're playing around with your projects and you're just trying to learn some skills, you don't have to necessarily worry about spending too much. The only thing you have to worry about is trying to manage your free tier and seeing your limits on certain things, but ultimately you can do that. So we can click on this link and then we can kind of dive into some of the actual perks of Amazon free tier. We talk about EC2 a lot. You have 750 hours of EC2 per month, which is quite a bit. You can do quite a lot with an EC2 instance by itself. Here you can have an S3 bucket, 5 gigabytes of free S3, so you can store all your passport photos, your birth certificates, blah, 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 in S3 forever, and you would never get charged for that. Amazon Relational Database Service, when you need a nice database for whatever reason you need, you have 750 free hours. A lot of other stuff too. Simple notification service. This is interesting because if you did the lab right, you got like the email sent after you completed a successful push to Git or push to the code commit. You can do that 1 million times without getting charged. So that's pretty cool. You can create your own newsletter for free, and you can have like 1 million different subscribers for free. And then there's also different container services, web app services, API gateway. This is nice, right? Because APIs are so important in SWE rules, and when you're building web stack, full stack applications, APIs are like the bread and butter of things. You have Amazon API Gateway to allow you to do those calls and to send those HTTPS requests without you having to worry about costs. So you have 1 million free HTTPS requests, and that's good when you have like a small website and you don't have too many customers. You don't even have to charge for that service as a whole. And yeah, there's even machine learning services. So you can kind of explore around in these free tier if you would like, and you can make some cool projects with that as well, free of cost. So yeah, those are the big reasons for AWS as a whole, why we talk about it so much. We have 3 more main services I want to talk about briefly, and then we can take a quick break. But these are the services relating to actual AWS infrastructure. So the 3 I want to talk about are local zones, wavelength, and an outposts family. So AWS local zones, let me see if I have the picture. Oh, no, I don't. So this is like a type of infrastructure deployment. So when you're running or spinning up your EC2 instances and you know that you want to have it targeted in a certain area of the world, or you have like a web application, but you know that a majority of your customers are in Europe or in China, you can take advantage of AWS local zones. So this allows you to, when you're spinning up resources and you integrate AWS local zones, you can actually spin them up in certain areas in which you choose. So if you know that a lot of people are accessing your content in Asia or Europe, you can specifically place databases or caches at those locations to make sure they have the quickest response times in their requests. So you can compute, store, or do data at any area in the world in which you select. So the goal of it is just to have the lowest latency possible and to have it be in most populated areas. Whoops, there we go. Yeah, so that's the icon. You can kind of see it in the diagram. Once you enable AWS local zones, you can build very low latency applications. So we talked about edge locations in the past, right? I mentioned it quite briefly in previous lectures. Edge locations, we use them in like context of like caching. So I want to talk about the differences because these might sound interchangeable, but they're actually quite different. So local zones, they're basically place your AWS services closer to a target of users. So I need a lot of EC2 instances in LA because I have built a platform that streams LA games, or like an LA sports team. I have an application that does streaming there. I can place them in the LA local zone. That way, all the people from LA have quicker access than people outside in like China who don't even know that this sports team in LA existed. So that's an example of that. We have, so yeah, that's what a local zone is. And in an edge location, this is more for caching. So when you think edge locations, try to keep in mind that means caching. So caches, remember, they're like, what's the word? It's ephemeral. It's content that doesn't stay or persist, and you just need it to be temporary. That's what caching is. You can store cache content in edge locations. That way, let's say someone in China for the first time accesses some content from your platform, and then you want to be sure that more people from China can access that content later, you can store that content in edge locations. That is like cache in an edge location. So yeah, the idea is, you know that you don't have frequent access in certain areas of the world. So like, you know, a lot of people from China don't access your content, but you want to be sure that when there's quite frequent, like an abrupt amount of requests to access your content, you have the ability to kind of lower the response time over time with caching. So yeah, those are the main differences. And then the second service, we're almost there, but AWS Wavelength, this is kind of a newer service. It takes advantage of the 5G infrastructure that's built across the world now. This allows you to have ultra low latency mobile computing applications. So basically what it does is AWS Wavelength embeds compute services. So things that need to compute in your like mobile applications, they can embed those services into the 5G network. So when you're trying to use those computing services through your mobile phone, the 5G network can transfer that computing service to you quicker. So it's kind of like, if you were to think about it, let me give you an example, an analogy. Like if I had an application that was like a GPS geo style application, right? And it's being used by a lot of users through their iPhone or Android or whatever. You can use AWS to kind of make sure that the computing service that actually handles the geolocation stuff, you can ensure that it's located across the 5G network so people can instantly access that service. So a better diagram to look at is this one. You can kind of see it just takes this huge, I guess, shortcut, and then now you have the ability to connect to whatever service you need through the 5G network. So yeah, it's like AWS has piggybacked off the AWS or the 5G network, and yeah, you can take advantage of ultra low latency. And this is mainly for mobile applications. So, you know, 5G is still a new technology, but it seems like there's already optimization that can happen when you're trying to connect to several thousands or millions of users at once. So yeah, that's AWS Wavelength. And then here's a better diagram. Like a developer has an application and they deploy in a certain region of the world. You can, in the region, have a wavelength zone where it just basically loads up whatever service you're trying to use. It embeds it into the 5G network, and then now your end users can use those services. So that is kind of the higher level view of it. And then lastly, almost there, this one's kind of fun because it was kind of like the Snow family that we talked about a while ago with individual like hardware that you can get from AWS. This is kind of the same idea. They're called AWS Outposts. So it's basically an AWS service that allows you to have on-premises hardware / infrastructure. You know, when you're wanting to build a hybrid model or a more majority on-premises model, you can actually buy / rent hardware from AWS to maintain those kinds of models. So there's two types. There's an AWS Outpost rack and an AWS Outpost servers. And then in each of these individual outposts, you can run AWS cloud services. So like, imagine you had an already running on-premises like system of servers, but you want to also be able to use AWS's services and you don't want to migrate everything to the cloud. You can buy an outpost and place it within your data centers. And then now you have access to AWS services without actually having to migrate to the cloud. So that is the primary use case. Let me show you kind of what they look like. So this is an Outpost server. This is kind of your server, you know, if you want to host a website, it has its own IP address, things like that. And then an Outpost rack is like a stack of servers. So they can get pretty big, and you can buy several hundred or thousands of these if you're trying to make a huge infrastructure, or you can buy like one or two for whatever use case. And it would work pretty much. And that's actually what AWS uses in their own data centers. The very same outpost service, although they don't look they don't look as similar, but they have like the same functionality. So yeah, you can basically just buy AWS hardware like this through Outpost. So yeah, to go back, some use cases of why we've used this. Let's say you're in China and you have information that's sensitive and that the government does not want to get out. I always use China for this just because of censorship, but data needs to stay within certain regions of the country due to regulatory reasons. This would be a good idea to use Outposts. That way you can kind of keep your information within the boundaries of the country or the boundaries within the region. Because remember, when you're using the cloud, you have no guarantee of your information being solely located in the region closest to you, right? Because you're blinded as a customer to where all the services are located. So, you know, your information, although it appears that it's closer to you in your region, it might be stored in like another AWS availability zone, for example. So this is like a good reason for why we want to keep it local and why we could use Outposts for that. And then you can set up your own IPs, things like that, to make your own network. Another thing is sometimes it's hard to migrate data locally. So when you have data that's already local and you can't really move it to the cloud, you can buy Outposts to take advantage of cloud services without having to migrate. Another thing is low latency computing, like multiplayer games. You can host like a multiplayer tournament, a CSGO tournament, or like very high volume, like you need the best performance possible. You can buy servers and then create your own like little hub for multiplayer games, for example. So very low latency computing, you can buy AWS services or Outposts to do that. And then sometimes when you have an enterprise scale application and you're trying to migrate it all into AWS, sometimes a lot of those servers, and there's a lot of dependencies within those servers. So like you can't just migrate everything all at once. You kind of have to split things up into pieces in order to migrate them at one in ultimatum. So what I mean by that is, like, let's say you had a database, but it has connection to some API endpoint here in the computing server. You can't just migrate those both at the same time. You have to kind of split the process up. Outpost is a way to do that. You can transfer your database onto an Outpost, and now your Outpost is connected to the cloud, and then do the same thing for the computing service. So yeah, that's also another use case for Outpost. And then last but not least, we have a break, the best server. So we'll take a quick 5-minute break, and then we will be back to finish it off with the networking aspect. And it's very short, so you all can come home early. So let me set a timer for 5 minutes. Alrighty. Alrighty, we're gonna continue the last half of the lecture and then we will wrap up. So now we're gonna be moving on to networking, so taking a sidestep from infrastructure. So networking, right? We talked about this, I believe, 3 lectures ago. There are some kind of complicated topics, such as like how they all work together, IP addresses, subnets, how those kind of work. But here's like a little recap and just an overview of what you need to learn or know for networking services. Basically, an IP address, to recap, it's the device address in a network where you can send and receive information. It's like the unique identifier. So much like an address of a house by mailbox, you can send things like mail through to that IP address or to the IP address. A device works the same way. You can send and receive packets of information at IP addresses. And then packets, to follow up, they're basically messages sent between devices that are connected at the IP level. And then the network, it's just the overlaying interconnectivity of all the devices. So all the IP addresses, a network encompasses all of that. And then a little bit more, a subnet is just basically a subset of IP addresses that are grouped together. And then we have something called a NAT. This is more of like a more technical networking topic, but network address translation, or NAT, is just a method of mapping a group of private IP addresses into like a public one that sends and receives information. So when you have a lot of IP addresses that are private, that have like certain devices connected to them, and you don't want them to be public, meaning you don't want people to, any other device to send information to it, we have something called NAT, which basically manages the sending and receiving of information for private IP addresses through a public one. So it's like if you had a bunch of kids in a room, the NAT is like the parents making sure that you're communicating for your kids in the room with outsiders, because you don't want people to talk to your kid without your permission. So that's a good analogy. And then a router is basically a device performing the routing of packets. So knowing what IP addresses get what packets of information. So yeah, those are just kind of the brief things you need to know. Not too important, but always good to know. So this is the biggest AWS service in terms of networking because it's so important. So Amazon Virtual Cloud, Virtual Private Cloud, it's basically a service that allows you to deploy your project or applications in like a more controlled environment called a virtual network. In this network, you can basically customize everything in terms of networks. Like you can customize the IP addresses. So when your services are interacting with other services that you've integrated, you can have different IP addresses set for different ones. So you can kind of control the flow of traffic and information. There's routing features, there's subnets, so you can group services together and you can group other services together and you can kind of maintain that connection there. So like, what does that all mean? And like, what does that look like? Let me kind of give you like a nice diagram to follow in the form of the city analogy. So a virtual private cloud is basically just like a giant city, right? It has everything ranging from, roads, cars, to buildings and like living spaces, security guards, security gates. VPC is just an entire city. Subnets are like individual postal codes. You have the opportunity to customize what goes into what subnet, and you can create subnets. So if you look, I'll enlarge this diagram later, but you look at this, each individual square is an individual subnet or like postal code, and you can dedicate certain services to certain subnets just for organization reasons and also because it allows for more controllability later. There's route tables that you can control, which are like roads. You can connect certain postal codes slash subnets and maintain the flow of information there. You can set up network ACLs, which are like security gates. Much like a firewall, you can kind of control what leaves and what comes out from certain IP addresses. You have the servers themselves or the services. These are like, S3, EC2, RDS. Those are like the individual buildings within your city. So you can kind of see how it all fits together. Services belong to certain subnets, much like buildings belong to individual postal codes, and they're all interconnected by roads, and they have security with security gates, all within a giant city slash VPC. And then you can add security groups, like controlling access to what with security guards, and then kind of like a even higher level look at things. You can deploy your VPC in different availability zones. And this is similar to having parallel dimensions of your city. So meaning, like, let's say a meteor hit your city in one availability zone, you have the same city in another availability zone, much like you have the same city in like a parallel dimension. So if one city goes down in one dimension, you still have the other city on the other dimension. That's what an availability zone is, kind of. When your VPC goes down in one availability zone, you have another one to do the same amount of work. So yeah, that's kind of like the analogy there. And then the regions are like alternate realities. Okay, this is even higher level. Regions are like when you have different parallel dimensions in one reality and then different ones in the other reality. So let's say you have a bunch of VPCs all across the world, or you have different VPCs in availability zones, right? Let's say you had one in a different region. That region has nothing to do with the region where the other VPCs are. So it's much like they're independent of each other. So this VPC that's set up in a different region has nothing or no link to the ones in this region. So much like alternate realities, something that happens in one reality can't affect the other reality. So this is kind of like a nice higher level look at things, and we can enlarge the picture. So yeah, the individual buildings, let's say this one's like a data center. This one's like an EC2 instance, and then it's all encapsulated by a subnet, which you can set the addresses for that subnet. You can control that. That's all much like a postal code. You have routing, so different information gets sent to different individual buildings that you can set up with like connections here. And yeah, you have multiple subnets and security guards, firewalls, and then this entire thing is the city. So the reason why VPCs are important is because when you want to organize things, when you want to keep all your databases in a certain subnet or a certain IP address, it makes things easier and makes things more controlled. And then when you set up other integrations, such as firewalls, it's easy to do so for an entire subnet slash postal code. So you can have like EC2s all in one subnet, and then databases all in the other, and then link them very easily and have like a nice architecture of how things are connected. That's why VPCs are important. Because without a VPC, your services are all across the world. You don't know where they all exist, and you don't know how they all connect to each other. So you can have a EC2 instance in China, a database in Africa, an RDS in like Europe, and they're all across like different regions of the world, and you have no control over how they're connected in like a higher level view. So you can kind of have like a virtual setting when you set like a certain IP address for those things. Now they're a lot more connected than you can have those controllability factors. So yeah, it's a little complex for the most part, but it's for pretty big enterprise things which require a lot of dependencies between certain services. But one more service that we want to talk about is AWS Transit Gateway. It's just like a cloud router. When you have different cities slash VPCs, you want to be able to bridge them together. you can now manage them with AWS Transit Gateway. It just connects all of the cities or all of the VPCs and then transfers traffic in one way or the other. So if you kind of look at this diagram here, if you have like a VPC of this address, you can control the flow of traffic through the network with AWS Transit Gateway. So like you can essentially think of it as like a connector for your VPCs. And it has like a lot of different services within each VPC. So that's Transit Gateway, and it's for some more higher level business applications. And then almost there, but AWS Direct Connect, this is just the way to maintain the hybrid model. You connect your on-premises networks to AWS services, not to get confused with AWS Outpost, because those are actual physical servers. This is just AWS Direct Connect, which allows you to connect on-premises servers to the cloud like that. So you don't need to actually buy hardware. It maintains the hybrid model. You can just basically have a network of AWS services that connect to your own data centers or your office, for example, and it's like a navigator. So it just maintains that link. So you have a VPC developed in the cloud with different services running different things. And then you also have your data center at home, right, that you want to maintain. You can connect those two now. So now the AWS services have a link to your own personal data center or your own personal network. So that's kind of the higher level look at things. It just navigates and connects. So yeah, you're looking at this diagram, you have a data center for customers. Direct Connect just takes those and creates a link to a VPC that you choose after you've created it. Cool. Last one, AWS Private Link. It's just a service to connect VPCs securely. The emphasis is on securely because like Transit Gateway like does connect VPCs. This one is like an add-on, another layer of secureness on top of that. So what I mean by that is when you have on-premises networks that need to connect to AWS networks, you need to make sure that when you're sending data across on-premises networks to AWS networks, that all that data is encrypted and private and secure. So this is a service to maintain the very high level encryption that you would want when you're sending very sensitive information from one network on-prem to one network on the cloud. So the private link is just a way to ensure that you don't have any bad actors in the world trying to access your information. Because let's say you have on-premises IP addresses that are public, but they contain very sensitive information. You can set up private link to make sure that while that information is being sent from the public address to the cloud, that no one can just intercept it or access certain information that doesn't need to be accessed. So yeah, that is what private link does. It maintains a private, secure connection between on-prem to your AWS cloud networks. And yeah, data migration is the main use factor. And I believe that is wrapping it off. I'm sorry, y'all. We got one more, Cloud Map. So this one is a little bit more easy to understand. Basically, when you create new versions of services that require IP addresses, this tool allows you to kind of automatically update IP addresses in integration. So what I mean by that is, let's say you have a backend service that has one IP address, and then you change it, and it has a new IP address. Now you have to go back and change the front end connection to the new versions of the IP address. So like typically in like a full stack kind of network, you have a front end service that connects to a back end service through IP addresses and APIs. Basically, when you update like the back end and then the IP address changes, now you have to go back to the front end, reset the the connection to the new one. And, that takes a lot of effort. Basically, Cloud Map is a way to take away that pain and struggle. It's like a dictionary. You have IP addresses mapped to different versions that automatically update when you create a new version. So don't know too much about the specifics, but when you have like a version here and you create a new version, it automatically integrates the front end service to that new version. So you don't have to worry about maintaining IP addresses and locations and other miscellaneous data like that. It takes that headache away from you. So yeah, this is important when your applications have dependencies like a front end to back end service. So yes, that is the last service that we will talk about in all of the cloud computing decals. So this one, it should be sentimental, but this is kind of a diagram to show that instead of having this manual inputting of new IP addresses, you can do it with Cloud Map automatically. So yeah, we wrapped up. We're almost done. We have one more lecture after the Thanksgiving break. Wanted to say thank you all for your continuous effort, for those of you watching the recordings and for those of you who are here. It's been a great learning experience and it's been a joy to work with you guys. I for sure learned a lot, even myself, and then I hope you all did too, and keeping up with the efforts. The next lecture is going to be, we're going to set it up, but we're most likely going to have a guest lecture. In our Cloud at Cal Club, we have some people working on like developer teams. So these guys actually have hands-on experience with like enterprises and doing consulting work. We're going to bring out one of them to kind of explain like a project they're working on, and you can kind of see a real-time hands-on application of AWS service knowledge and things like that. So you can see like an architectural diagram of the project they're working on, what services they're using, and what goal they're trying to accomplish. So that should be really fun. Yeah, we're going to get that set up, but I'll still be here. In the last lecture, we will just have someone else taking it away. So that is all for today. Here's the attendance code. The attendance code is strike in honor of the GSI strike. Unfortunately, the strike doesn't necessarily pertain to decal lectures or like decal staff because this is like independently run. So we don't have like benefits or anything. This is kind of like volunteer work. But I still support the movement. Unfortunately, yeah, we're kind of like a different thing. But yeah, still applies though. It's good that they're requesting nice benefits. They work very hard, I'm sure. So yeah, that is it. And then after that, you are all free to go. Remember, lab 2 is due Monday. So if you need any help, email me at the CLAC email, clacloudcomputing.com@gmail.com. You can post on Ed, and then final project will be released Monday. It'll be nice, it'll be easy, it'll be free, and it'll take less than a few hours. So yeah, that is it. Almost getting close to the end of the semester. And then keep a lookout for all the grades that we're going to be inputting soon. Cool. Thanks. Okay, let me stop the recording.